have today. Now with us is Milica Mićić from company Into. She's one of the winners of first European Big Data Hackathon, and she will tell us about their solution, EU Jobs and Skills Explorer. Milica, please.
Thank you. So now something a bit lighter coming from the industry. It is my pleasure today to tell you a story about our team of data scientists winning the first place at the first EU Big Data Hackathon that took place in Brussels in March this year. The competition was organized by the European Commission and Eurostat, and the idea behind this event was, in the first place, to solve statistical problems by leveraging algorithms and available data. But it was also to try to identify the best class of data scientists in Europe, to promote and accelerate the use of big data in statistical initiatives in Europe, and to promote partnerships, collaborations in between research community and private sector. And in the end, to come up with and to produce innovative products and tools, and including visualizations. We have seen this as a great opportunity to test and compare our skills and knowledge with other best data scientists in Europe. And it really feels great to win the first place. So I'm going to walk you through some information about our team, our company, who we are and what we do. I'm going to show you some timeline of the entire process that involved in this competition, give you some details of each step on the way. And in the end, I'm going to show you the live demo of the prototype of our solution that was evaluated as the best. As for the team, the people you see in this slide are the core team of our data scientists. Igor Kalužer is our best analyst, probably the best I've met so far. He has a long history of working in banking, and he's currently a PhD candidate in University of Zagreb. Leo Mršić is the CEO of our Into Data company, which is part of our regional group called Into. He has more than 20 years of experience of leading teams in very different sizes, in experience in various business areas, and he also has a PhD in statistical analysis from the University of Zagreb. Robert Koppel is the Vice Dean of Algebra University College. He is a very experienced scientist, a long history of doing that. He has a PhD in economics as well, and is very involved in political science nowadays. And myself, I have a PhD in astrophysics. I'm expert for numerical simulations and data analysis, and I transferred to industry last year. Overall, we have more than 18 years of work experience in basically analytics. We are very active in business, education, government community. We all either have PhDs or are on the way of getting ones in advanced analytics. We are very committed to scientific work, to writing and publishing papers, writing and publishing books that are data science related. We are present and involved in many conferences, lectures. We are all data economy oriented, and we have quite a few experts for data monetization. As in the company, our team now counts 8 members of data science, and they're all data scientists. Beside us, we have an expert for sound analysis, for text and NLP analysis, we have a statistician, we have a hacker, very good one, and so on. We don't have preferences when it comes to tools we are using. We are very comfortable in using any of these tools you see on the slide. We are very good and experienced in Python and R. We are also regional partners for Tableau, which is advanced software for visualization. But we are using all other projects like from IBM and from Azure Machine Learning, SPSS, etc. CGI is our strong partner in doing data science projects in recent years. the part of our business model is to offer two types of products. One type of products is to build and develop analytic platforms, the place where you have your data integrated and ready to build the second part of project, the type of products, the analytical products, that you build models on those data you have in platform. Once you have that in place, then you can focus on your business value and the business insights. So far, we have more than 60 products and customized solutions in various areas, fields, from finance, retail, telco industries, political marketing, and we've done all range from credit risk, fraud, customer segmentation, acquisition, profiling, churn, or political network analysis, etc. So the main idea of our business model is, as I said, first to have all your relevant data integrated in a platform which is ready to build analytical models. Then you build one model, or few, that is industry related. And once you have that in place, you can engage yourself in further model development that will help you unlock business values. And once you have a constant model improvement, you can engage yourself in transferring that knowledge and do some education and training further. The hackathon itself, everything started in October last year, when our team was appointed by National Bureau of Statistics. This team presented Croatia in this competition. You figured that out. And in January this year, the goal was announced. All we knew at the time is that we're going to deal with one of the most important one of 10 important questions in European Union and European Commission. At that time, we started preparing our team and gathering support. Then data sets were supposed to be released at that time, but they didn't happen. It happened just a few days before the competition in March. Then the policy question itself was announced on the first day of competition, the 12th of March. And the competition lasts for 2 days, in practice 2 days and 3 nights. And on final day, each team had a 6-minute pitch to present the solution they came up with. And then afterwards, we had some follow-up actions of promotion and conferences and, of course, monetization of our results. Let's see in the details. This is the official letter we received from National Bureau of Statistics in Croatia, that our team, or these 3 guys, are appointed to represent Croatia in Brussels. There were 10 teams nominated or competing to represent Croatia. And our competences actually made us to be evaluated as the best ones to do so. The core team was, as I said, these 3 guys and the rest of our Into Data team. But we were also supported by people from National Statistics Institute in Zagreb, the Croatian part of EURES, Data Employment Service, and Faculty of Law. The European Commission sent 28 invitations to participate in this competition. 6 of them said that they do not have competence to participate. The rest, 22 teams, are coming from 21 EU members. Finland had 2 teams. In total, around 65 experts. As I said, it took 2 days and 3 nights, and at the end, each country had a 6-minute pitch. The data sets that were released are comprised of around 5 million records of resumes. It's a European job migration database portal. 35 million of records from job advertisements. And we also use some data scraped from the web. It's CDFOP database that are very popular but public portals for job advertisements. And we had a few million records of official European statistics surveys about income, living conditions, about adults that are involved in further education to improve their skills, and a labor force. The policy question itself came, so the policy domain that was selected on the first day of competition was skills, education, and lifelong learning. That is one of the top 10 priorities in Europe. And to see better, the policy question itself was, how would you support the design of policies for reducing mismatch between jobs and skills at regional level in the EU through the use of data? Each team had necessarily to use big data source and ideally to use European statistics. They also had to demonstrate the work through a tool that performs data analytics. This is the most important parts of these policy questions, but everything in red you see here is the different aspect of this question, and you were supposed to address as many as you can in these 2 days. So when you think about this, a problem, you realize that everything comes down to the skills and competence a person has. It's not about qualification, it's not about occupation, it's about the skills they have or have gained through this qualification or occupation. So basically you have to decompose those qualifications and occupations on a matching skill level. So let's see what are the activities we had to do in those 2 days, how the process goes. First, we had to choose or select the platform we are going to work with. The first issue we came across was combining the data. Data was not cleaned, it was not verified, and the final data sets were changed the day before competition. So basically, you have a very time-consuming job to do in the beginning of competition. The second issue we faced was how to structure the data. So how to structure the skills you're going to extract from the data, and how to handle the very big, large data sets you have. Our output includes 20 tables, and each having in average 100 and 120 million records. And the biggest one here, you see in the slide, has almost a billion records, and is 250 gigabytes in size. So we also had to deal with data optimization to define the project scope after we heard the policy question, to decide how and what we're going to address, to do the data processing and analytics analysis, develop and decide on visualization that is scalable, and present that, and that in just 2 days. So what we did, we chose Google Cloud Platform to run the entire system. We load all raw data into Google Cloud storage that we use as a data lake. Some of the data were in SQL database, so after some initial preparation, we loaded all data into Google BigQuery. That is an analytical database that is able to scale to billions of rows in extreme query performance. For the most data preparation, processing, and modeling, we use Google Compute Engine. That is the instance that has 64 CPUs and 240 gigs of RAM. It also has accompanying software, Debian operating system. It has Jupyter Hub for multi-user collaboration. It has R and Python, and also for multi-user collaboration install, various libraries that are needed, etc. For very large data processing, we used Google Dataflow. That is the next generation processing system out there. And then we loaded all the output data into BigQuery again. And we decided to use Tableau, advanced software for visualization, as our front end. Tableau actually was our secret weapon. It allowed us to move much quicker and to produce results that are in higher quality than the teams using other products. We'll see later when it actually showed the best of itself. We made 12 interactive dashboards that are embedded in the web, so that the public, we made it available to the public, and that they can access them through different devices. So as the prototype itself, we structured the main policy question into 4 areas: skill supply, skill demand, skill mismatch, and policy action that you can decide to take to close the gap between supply and demand. I'm going to try now and show you live. So this is completely in the cloud, and it's operating live on data, so it does take a moment to load. Let me see. It didn't scale well. I'm going to just turn off the mirroring. Turn on the mirroring, actually. Okay, I'm very keen to show you live version instead of screenshots, so we might do this way as well. This is the website, so on the web. So here you have your menu with all the, each area has 3 interactive dashboards showing different aspects of the area. For the skill supply, we use the URAS CV database to find the skills that are most in supply across all regions. And as you remember, one of the key tasks from the questions is to show across all regions, and Europe has these so-called NUTS regions. This is where Tableau actually saved us a lot of time. Out of the box solution support for these regions, and they have this support for these regions, which means they already have shapes of these regions that you can use in your map. So basically, as I said, you can see the number of skills in demand, or CVs that are out there across all countries. You can interact. You can choose different region level. And all the skills are also classified to European skill, competence, qualification, and occupation classification level. You have 4 of them. You can choose either that. Just remember, this is analyzing hundreds of million lines at the moment, so sometimes, depending on the internet connection, it can take a moment or 2. So basically, you can see all those regions. If you choose a country, for example, it's going to show you the situation in that country and the regions of that country. We also identify the top skills that are in supply across each of the regions in Europe. We were also looking at the skills that are clustered or related. We were looking for skills that are often found together in a CV or a job ad. We identified around 300 clusters of skill sets. Then you can go and play with that. And we were also identifying the obsolete skills, for trying to find a difference between population that is working and population that is unemployed or inactive. So you're going to find that what makes the difference between those two is actually the skills they have. I'm loading this to show you that I guess everyone is going to be happy that math and statistics are the least obsolete skills. As for the skill demand, we measure the demand by using URAS job advertisement database and, as I mentioned, the data scraped from the web. We calculated several demand measures, like a number of job ads that are demanding a particular skill. we measured the median and the average time between the CV was activated and deactivated, which help us later to analyze the attractiveness of the skills. And we identified the top skills that are in demand, again, across all regions and with all ESCO levels of skills. We built a prediction model of demand showing, using, I forgot to mention that, I'll just go back on the previous, that all the data you can look into time series. There is a data for the last 2 years, and this is aggregated on a monthly level, but that was our choice, but you can do it in even lower level. So we did a prediction model that was saying that public relations is going to be the skill, the most wanted skill in this year. Okay, then I'm gonna go a bit quicker. We also analyzed the complexity of occupation, basically to identify the occupations that are changing the most rapidly in terms of skills they require. At some point in time, you had a qualification that required a specific skill set, and then like 6 months later, it requires even different skills or very broader range of skills. So you can look at that. We were addressing the question of mismatch between supply and demand by defining an indicator. There is actually a number of job ads requiring a particular skill over a number of CVs with that skill, across all regions and all levels of skills. To try to identify which regions are the ones that have biggest mismatch. We can see that this is Austria. Also, we identify the skills that have biggest mismatch between the supply and demand. We were looking at occupation migration, basically taking into account the current occupation of this job seeker and the occupation they desire. Okay, then I can maybe cross faster. We also show correlation between various socioeconomic indicators and how they correlate to skill supply. You can choose that, so we'll just load the plot. Okay, so here you're going to have countries. You can choose the country, and it's going to show for each region. You can choose the indicator. You can choose the skill set you want to see how it correlates. For the policy actions, so I'm just going to load this one, but we were looking at the gap between the skills and qualifications. We were using surveys to measure the population that is involved in education, further education to improve their skills. We are currently working on measuring which regions offer which type of education for particular skill, but we don't have that yet. And what we did, we measured the workforce migration, taking into account the current region of the job seeker and the desired region that they want to go. Croatians, for example, traditionally want to go to Germany or Ireland, which is not a surprise. We also measure the attractiveness of skills. So as I said, we look at the time between CV was activated and deactivated, assuming that the job seeker found a job, and that the quicker that happened, that those skills that he has in those CV is more attractive. So this solution, so basically that's alive again in 2 days. We are not in PowerPoint, okay. So there were 2 panel evaluating panels. It was a statistical panel that combined of experts from European institutions and academia. These are their names. Maybe you recognize some of them. And the second panel was from industry. It was combined of representatives for different technical vendors. As you can see, many of them or all of them are from Microsoft, Oracle, SAP, IBM, etc., and they're all competitive to Tableau, and we still won. So basically, this is the place where Tableau showed where it excels, its functionality and productivity at the same time. And these guys evaluated this project as the best. So to sum up, we ended up with a fully functional web application that has interactive interface, allowing further analysis, enabling policy analysts to make use of the available data to provide informed design of appropriate policies, to gain an insight into 4 key areas, and in general, to gain an insight into characteristics of the labor market across Europe. And this is where you come into play. We are very happy to hear your suggestions, your ideas, your guidance to help us develop this project into something that's going to really be in use. Of course, there's a lot of room for methodological improvement, which we will be happy to do. And please feel free to use these credentials to either contact us or to use and place this model. As I said, it's available, it's online. You just need this password to access. The data itself are public, but the system is not. And I will be happy to answer your questions. Thank you.
Milica, thanks a lot. Questions, please?
Okay. Did you choose Google BigQuery engine because of Python and R? You said that your team are expertise in Python and R.
No, yeah.
Only because of that?
No, we use this engine because it's its performance. It has, so the compute engine has very extreme query performance. We have with hundreds of millions records you need to deal with that. So that's why we use Google Platform, I guess you're asking. And then you have everything in one place. So the solution is completely in cloud. Mm-hmm. But it is accompanied with the tools we are very good with.
Okay, thank you. And I have a second question. Do you use some stream jobs to update these graphs? Or everybody function as a batch? Stream jobs, streams.
I have to say that that's the question for our technical guys, how they use for the data manipulation. Yeah.
Okay, thanks.
So I'm not sure I quite understand how was the final result evaluated. So you show those yeses of judges.
Because
was there any quantitative
because this was a job for 2 days. It doesn't, so we came out with a tool. We didn't come with the conclusions. We leave that to experts to make a conclusion by playing with this data. But data is live. It's not a proof of concept. So basically what other teams did, they used one product. They had very limitation. They didn't have live solution, and they did proof of concept. And they answered maybe 1 or 2 aspects of the questions because it just had 2 days.
But you didn't have any quantitative test at the end, or ground truth, or data, or anything?
No. And it's open for further development.
Okay.
Yeah.
Just a short one more. Okay, if not, Milica, thank you very much again.
You.